Bismillah ar-Rahman ar-Rahim. We are interested in these sums. Let's start by the left-hand side. So we have summation n from 2 to 13, tan 2 to the n degrees minus tan 2 to the n degrees minus 45 degrees. Insert plus tan 2 to the n plus 1 degrees minus tan 2 to the n plus 1 degrees. And then split this summation into two sums. One of them will be this summation n from 2 to 13, tan 2 to the n degrees minus tan 2 to the n plus 1 degrees. Now, this summation here is telescopic. So if n is equal to 2, we have tan 4 degrees minus tan of 8 degrees. If n is equal to 3, we will have plus tan 8 degrees minus tan 16 degrees. If n is equal to 4, we have tan 16 degrees minus tan 32 degrees. So this will go with this will go with this, and so on. So we end up with tan 4 degrees minus tan 2 to the 13 plus 1, or 2 to the 14 degrees. And now these two values are exactly the same. So this summation here is equal to 0. So the sum that we have on the left-hand side is exactly equal to this sum. So it is summation n from 2 to 13, tan 2 to the n plus 1 degrees minus tan 2 to the n degrees minus 45 degrees. So if theta is 2 to the n, this is tan 2 theta minus tan theta minus 45 degrees. And tan 2 theta minus tan theta minus 45 is exactly sec 2 theta. Okay, so we can prove this here. We can go from this side to this side or the other way. Let's start from here. Sec 2 theta is 1 over cosine 2 theta. We have cosine, double an angle. So this is 1 over 2 cosine squared theta minus 1. Multiply numerator and denominator by sec squared theta. Numerator becomes sec squared theta. Denominator becomes 2 minus sec squared theta. Now we know that sec squared theta is equal to 1 plus tan squared theta. So in the numerator, we will have 1 plus tan squared. In the denominator, we have 2 minus 1 plus tan squared theta. So now the denominator is 1 minus tan squared theta. Now to this term here, we add and subtract tan 2 theta. So recall that tan of a plus b is equal to tan a plus tan b over 1 minus tan a tan b. And if b is equal to a, then we have tan 2a will be tan a plus tan a, that's double tan a, over 1 minus tan squared a. So here again we inserted tan 2 theta and then minus tan 2 theta, but now written as 2 tan theta over 1 minus tan squared theta. These two guys, they have the same denominator, so let's combine the fractions. 1 minus tan squared theta here downstairs, and then upstairs in the numerator we have 1 plus tan squared theta minus 2 tan theta, which is 1 minus tan theta all squared. In the denominator we have the difference between two squares, so this is 1 plus tan theta, 1 minus tan theta, and so we can simplify this fraction to 1 minus tan theta over 1 plus tan theta. Now, again, if we go to this formula for the tangent of a sum of two angles, now if B is equal to minus 45 degrees, then tan minus 45 degrees is minus 1, and so this will become tan A minus 1 over 1 plus tan squared tan A, or 1 plus tan A. So if we look to this term here, 1 minus tan theta over 1 plus tan theta, this is exactly minus tan of theta minus 45 degrees. So tan 2 theta minus tan theta minus 45 degrees, this is sec 2 theta. So if we go back to our left-hand side here, again, left-hand side, insert tan 2n plus 1 with a plus sign and minus sign, split the summation into two sums, then the first telescopic sum will give us 0, and then the second sum, rather than being written like this, we can use this equality here, this identity, and rewrite this as summation n from 2 to 13 sec 2 to the n plus 1 degrees. So we have these two sides now are equal, and what is left is to show that this summation is equal to 24. What are those angles? Well, if n is 2, then we have 2 to the 3. So we have 8 degrees, and then we have 16 degrees, and then we have 32 degrees, and so forth. Now find the remainder of those angles when divided by 360. So find the angles modulo 360 degrees. So those angles will be 8 and 16 and 32 and 64 and 128 and 256. And then there is 512 degrees, and 512 degrees is 360 plus 152 degrees, and so on. So take all those angles modulo 360 degrees. And so those are the angles that we have. Because we are interested in sec, and sec is the reciprocal of cosine, then we can exploit the fact that cosine 180 degrees minus theta is equal to cosine 180 degrees plus theta, which means that if we have an angle here that is above 180 degrees, let's say that we have this angle which is 184 degrees. So this is cosine 184 degrees is equal to cosine 180 degrees plus 4 degrees. So according to this identity, this is exactly equal to cosine 180 degrees minus 4 degrees. So this is cosine 176 degrees. So I can replace this 184 degrees by 176 degrees, and so on and so forth. So that now we have angles, all those angles are in the range between 0 and 180 degrees. Again, we are doing this because by the end of the day, we are interested not in the exact values of those angles, but in the reciprocal of the cosine, the sec function. So those are our angles. And now if you stare at those angles, what is the sum of sec 8 plus sec 16 plus sec 32 and so on? Is there any feature that that unites all those angles? So here is the key observation. The key observation is that any angle here in this set of angles, if multiplied by 15, you will get an angle whose cosine is minus 1 over 2. So if you take 8 and 8 times 15 is 120. And what is cosine 120 degrees? It is minus 1 over 2. Now you can do the same to all the angles. So for example, 16 degrees times 15, it gives 240 degrees. And cosine 240 degrees is minus 1 over 2, and so forth. To recap, we have our angles expressed like a geometric progression. We have the angles are 8, 16, 32, 64, and so on. Now we can write them down in the range from 0 to 360 degrees. And then we can say, well, we are interested in the reciprocal of the cosine. And since cosine 180 degrees minus theta is cosine 180 degrees plus theta, then I can express all the angles as angles between 0 and 180 degrees. And then we need to examine those angles, spend some time trying to find what can be common among all those angles. We will discover that each one of those angles, if multiplied by 15, will give you an angle whose cosine is minus 1 over 2, minus 1/2. So the angles satisfy cosine 15 theta is -1/2. And so if you have cosine, let's say alpha is equal to -1/2, then what are the solutions? Then alpha is 120 degrees plus integer multiples of 360, or 240 degrees plus integer multiples of 360. So we have 15 theta. So it is that 15 theta is in the form of 120 degrees plus integer multiples of 360 degrees, or 240 degrees plus integer multiples of 360 degrees. Now divide both sides by 15. And so we will discover that if we hunt for the angles that satisfy this equation, that the angle multiplied by 15 has a cosine of -1/2, those angles will be in the form of 8 degrees plus 24 degrees times m, where m is an integer, or 16 degrees plus 24 degrees times m, again m is an integer. So again, 8 here and 16 here, and 24, they come from dividing 120, 240, and 360 by 15, by this 15 here. So now the solutions between 0 and 180 degrees will be those angles. So those are the angles, those are the 15 angles that has this particular property. Multiply by 15, take cosine, you get -1/2. Most of the angles that we have here, or actually the angles that we have here, include the angles in our problem. They include the angles in our problem, plus 3 extra angles. In our problem, we have exactly 12 angles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And basically this 12 comes from the number of terms in this summation. The number of terms in this summation is 13 minus 2 plus 1. We have 12 angles. Now, if you ask yourself how many angles between 0 and 180 degrees satisfy the property that 15 times the angle is -1/2, you will get 15 solutions. So we have our list of angles, and in addition to this, we have also 3 extra angles, and those angles are specifically 80 degrees, and 40 degrees, and 160 degrees. So we have those 3 angles. Remember, we want the sum of sec 8 and sec 16 and sec 32 and so on. Now, we can get the sum of sec 8 plus 32, the sec of those guys which satisfy this property. But then we also need to find what is sec 40 plus sec 80 plus sec 160 degrees, so if we know this sum, so if we know some sec of those angles, and if we know sum of sec of those angles, okay, then by subtracting, we will get the sum that we are interested in, and hopefully the number that we get is 24. Let's start by the sum of these 3 angles. What is sec 40 degrees plus sec 80 degrees plus sec 160 degrees? Now, one way of obtaining this sum is to note again that those angles satisfy the property that if you take any of those angles multiplied by 3, you get a cosine that is -1/2. So those angles, they come from solving the trigonometric equation cosine 3 theta is equal to -1/2. And so 3 theta is 120 degrees plus integer multiples of 360 degrees, or 240 degrees plus integer multiples of 360 degrees. If we divide by 3, then theta is in the form of 40 degrees plus 120 degrees times an integer, or 80 degrees plus 120 degrees times an integer. So what are the angles with this property? The angles between 0 and 180 degrees, we have exactly those three angles satisfying this property and no other angles. So this is very good news. It will allow us to basically obtain sec 40 degrees plus sec 80 degrees plus sec 160 degrees. The trick is to express cosine 3 theta using cosine theta. So we know the formula for cosine triple the angle. Cosine 3 theta is exactly equal to 4 cosine cubed theta minus 3 cosine theta. And then we can take this minus half and move it to the other side. So we have a cubic equation in cosine theta. We have 4 and then cosine theta, think of it as a variable, cubed minus 3 and then cosine theta plus 1/2. That's a cubic equation, and this cubic equation is satisfied by those angles from 0 to 180 degrees, 40, 80, and 160 degrees. Now, we are interested in the sum of sec 40, the sum sec 40, sec 80, sec 160. Well, now our friend are the Vieta's formulas. This equation are cosine 40 degrees, cosine 80 degrees, and cosine 160 degrees. Those are the angles that if you multiply by 3, the cosine will be minus 1/2. Now, according to those formulas, the product of the rules is negative this number divided by this 4 here. So cosine 40 times cosine 80 times cosine 160 degrees, this is minus 1 over 2 divided by 4, that's minus 1 over 8. What else can we say? Well, this coefficient here, which is minus 3, if we divide by 4, this will give us, so the, the roots, it will give us the roots multiplied pairwise. So minus 3 over 4 will give us cosine 40 times cosine 80 plus cosine 40 times cosine 160 degrees plus cosine 80 degrees cosine 160 degrees. And so this again will be this coefficient here divided by 4. Now take this expression, divide by that. And so cosine 40 times cosine 80 divided by this product, this will give us 1 over cosine 160 degrees. And when this term is divided by this product, we will get 1 over cosine 80 degrees. And when this term is divided by the product, we will get 1 over cosine 40 degrees. So dividing this minus 3 over 4 by minus 1 over 8 will give us the sum sec 40 degrees plus sec 80 degrees plus sec 160 degrees. And so this will be minus 3 over 4 divided by minus 1 over 8, which is exactly equal to 6. So the sum of sec 40, sec 80, sec 160 will be 6. Okay, so let's recap this because this is the idea that we will also use to obtain the sum of the secants of those 15 angles. Again, the idea is we have 3 angles, 40 degrees, 80 degrees, and 160 degrees. 160 degrees. Okay, those angles, what is common between them, or one of the things that is common between them, that if we take any of those angles and we multiply by 3, then we get an angle whose cosine is minus 1 over 2. And so we ask ourselves about what are the solutions to the trigonometric equation that cosine 3 theta is equal to minus 1 over 2. in the range between 0 to 180 degrees, those are indeed the solutions. Those are the three angles that if we multiply by 3, we get a cosine of minus 1/2. We are interested in sec 40 plus sec 80 plus sec 160. So the way to go is to express cosine 3 theta as 4 cosine cubed theta minus 3 cosine theta. Then we can have a cubic polynomial equation by moving this minus 1/2 to the other side. So this is our equation. It is a cubic equation in cosine theta. So this is a cubic equation whose roots are cosine 40 degrees, cosine 80 degrees, and cosine 160 degrees. Now, we are not interested in the exact value of any of those guys. We are interested in basically this summation here. So just looking at the polynomial equation, the cubic equation, we know that the product of the roots is minus half divided by 4. And we know that if we take the pairwise product and sum, so if we take cosine 40 cosine 80 plus cosine 40 cosine 160 plus cosine 80 cosine 160, this will be this coefficient here, which is minus 3, divided also by 4. The desired sum is basically this equation divided by that equation. And so this summation is minus 3/4 divided by minus 1/8, and this is equal to 6. Using the exact same method, we can obtain the sum of sec 8 plus sec 32 plus sec 56 and so on. And if we obtain that sum, then we subtract 6, and then we have our desired result. Here, for those angles, we will use an idea that is very similar to what we have here. What are those 15 angles? Those are angles satisfying the trigonometric equation that cosine 15 theta is equal to minus 1/2. Okay, and so those are angles in this form. Now, as we can express cosine 3 theta in terms of the cube of cosine theta and cosine theta, this can be done to any cosine n theta. Okay, so cosine 15 theta can be represented as a number times cosine theta to the power 15 plus a number times cosine theta to the power 13, and so on. We have a polynomial equation of degree 15 in cosine theta, and the roots, okay, so this 16,384, so this is 2 to the 14. Then we have cosine theta, or to the power 15, and then we have this number, we have cosine theta to the power 13, and so on. So this is a polynomial equation in cosine theta, and the solutions, or the roots, what are the roots? Cosine 8, cosine 32, cosine 56, and so on and so forth. Now, what is this 1/2? Now, if we take this 1/2 and have a minus sign divided by this coefficient here, which is 2 to the 14, this is the product of the roots of the polynomial equation. So this is cosine 8, cosine 32, cosine 56, cosine 80 degrees, and so on. What about this coefficient divided by 2 to the 14? So minus 15 over 2 to the 14. This will be the sum of the product of those cosines, excluding one of them at a time, right? So there will be cosine 32 degrees, cosine 56 degrees, cosine 80 degrees, excluding cosine 8. And then there will be another term in which we exclude this one, cosine 8 degrees, cosine 56 degrees, cosine 80 degrees, and so on. Okay, so on. Plus, So we take basically this coefficient divided by this, is you take the product of the roots excluding one of them, and then you sum the terms. What we are interested in is sec 8 degrees plus sec 32 degrees plus sec 56 degrees. So what we can do is that we can divide this by that. So this is the sum excluding cosine 8. So when we do the division, when we take minus 15 over 2 to the 14 divided by minus 1 over 2 over 2 to the 14, what we get is 30. And what is this 30? When we divide this by that, we get 1 over cosine 8. And then when we divide this by that, we get 1 over cosine 32 degrees. And when we divide this by that, we get 1 over cosine 56 degrees, and so on. Then we get sec 8 plus sec 32 degrees plus sec 56 degrees plus sec 80 degrees, and so forth. And this is basically a sum that is equal to 30. So this is the sum of those 15 angles between 0 and 180 degrees that satisfy the trigonometric equation that cosine 15 theta is equal to minus 1/2. Our original interest in this problem is the sum of 12 of those angles. But we discovered earlier that the 3 extra angles, sec 40 plus sec 80 plus sec 160, the sec of each one of those angles, if we sum, we get the value that is 6. So our desired result is 30 minus 6, so 24. And by this identity is established.